So, when you catch an AI in a lie, I think your first instinct is probably to just blame the code,
Well,
right?
yeah.
You think it's a bug, like a glitch, a temporary failure in the matrix that some developer in Silicon Valley is going to just patch in the next update.
Right, a quick fix.
Exactly. But what if the problem isn't actually the machine? What if the most dangerous thing about artificial intelligence is actually that, well, human biology has basically evolved over thousands of years to fall for its lies every single time?
Yeah, and that is a really uncomfortable reality we're waking up to right now.
It really is.
Because we are approaching this completely revolutionary technology with, outdated mental software, and it is making us incredibly vulnerable.
And that vulnerability is exactly what we are going to unpack in today's deep dive. So, before we jump in, I want to mention that today's deep dive is presented by Dr. Christophe DeLong and Connexa Formation. And we are looking at a really fascinating document they've highlighted called The User Face to AI, The Illusion of Determinism. Or, if you want the original French, it's L'utilisateur face à l'IA, L'illusion du déterminisme.
A really eye-opening paper.
It truly is. So our mission today for you listening is to basically map out why we blindly trust these systems, the literal mechanical reasons why they break down, and, how to build a cognitive defense system against them.
Because we are living through this massive paradigm shift.
Right. And most of us don't even realize the ground has moved underneath us, do we?
No, not at all. And it's not just that the ground moved. The entire foundation of how humans interact with machines has been entirely replaced.
Wow. Okay, how so?
Well, think about the last 50 years. We've been conditioned to use what computer scientists call deterministic systems.
Deterministic, meaning what exactly?
Basically, think about every single tool you've ever used before, say 2022. Traditional software, spreadsheets, pocket calculators, they all offer a very specific, rigid kind of reliability.
Oh, like cause and effect.
Exactly, cause and effect.
So if I type a command, the machine executes that exact command based on a really strict set of rules. Like, I hit save, the file saves to the hard drive.
Right.
Or I type 2 plus 2, I get 4. Always.
Always 4, never a 3, never a 5. The system is governed by these underlying logic gates and hard-coded rules.
It's binary.
Yeah, and because of that, we have spent decades, literally generations now, building up this deep subconscious trust in that binary predictability. If the machine gives you an output, it's a verified fact. It's based on the code.
But AI isn't like that.
No. Now we are interacting with large language models, generative AI, neural networks, and these are probabilistic systems.
Okay.
They do not play by the rules of cause and effect at all.
But the interface plays a massive trick on us here, right? Because I'm sitting at my same desk, looking at the same screen, typing on the same keyboard into a text box that, frankly, looks exactly like a Google search bar.
Yeah, it feels identical.
It feels like the exact same tool.
And that visual similarity is a total trap. Because it looks like a traditional computer interface. We indiscriminately transfer that decades-old trust from the deterministic machine over to the new probabilistic one.
We just carry the trust right over.
Right. But underneath that text box, there are no hard-coded rules for generating absolute truth.
None.
None. Instead of predictable reliability, probabilistic systems offer what we call variable plausibility.
Variable plausibility.
Yes. They operate purely on the statistical probabilities of language.
Okay, let's slow down on that phrase for a second. Statistical probabilities of language, because I really want to make sure the mechanics are crystal clear for everyone listening.
Sure.
When I ask an AI a question, it's not going into like a vast database, finding the factual answer and bringing it back to me.
Not at all. That's the illusion. It is literally just predicting the next most likely word in a sequence.
Wait, just the next word?
Just the next word. It looks at the prompt you gave it, calculates millions of data points from its training, and decides statistically what word should logically follow. Then it calculates the next word, and the next. It's an engine designed for linguistic engineering. It is not designed for factual retrieval.
Okay, so it's like we're trying to use a highly creative writing partner, but we're treating them like a pocket calculator.
That is the perfect way to visualize it.
Like we expect them to crunch hard facts, but their brain is just trying to write a really compelling, statistically normal sentence.
Exactly. And this brings us right to the core psychological trap of the whole thing.
Which is?
Well, if we accept that it's just predicting words based on statistics, we really have to ask ourselves why we find those predictions so utterly convincing.
Yeah, I struggle with that part. Because in the real world, if I ask a human being a question and they're just guessing or, spitballing, I can usually hear it.
Right, you hear the cues.
Yeah, I can hear the hesitation in their voice, or they use filler words like I'm doing right now, or their argument is just a bit disorganized. So why doesn't the AI sound hesitant when it's just guessing?
Because its primary objective,
Yeah.
what it has been endlessly trained and optimized to do, is to produce text that is stylistically coherent and grammatically impeccable.
Flawless execution.
Flawless. It never stutters. It never says, it delivers every single statistical guess with absolute structural confidence.
Wow.
And that triggers a deeply ingrained cognitive shortcut in our brains. It's a phenomenon called the linguistic authority bias.
Linguistic authority bias, meaning we inherently trust people who sound smart.
We don't just trust them. Our biology actually demands it.
Really? Biology?
Yeah, think about the thousands of years of human communication. High-level linguistic mastery, the ability to speak with perfect grammar, clear structure, and absolute confidence.
Right.
That historically required deep factual knowledge and education. You just couldn't sound like an expert unless you actually had the expertise.
Oh, I see.
So the human brain basically evolved to use the formal quality of language as a proxy for the truth.
That is wild. We are literally being hacked by good grammar.
Completely act.
Like, we hear a beautifully structured 5-paragraph essay with bullet points and a strong conclusion, and our brain subconsciously signals, oh, this entity knows exactly what it's talking about.
Yep.
Even though the entity is just running a math equation on vocabulary words.
Exactly. We are completely bypassed by fluency. But there's also a secondary, highly practical reason we fall for it.
Okay, what's that?
The source document presented by Dr. DeLong and Connexa Formation highlights the cognitive cost of dealing with AI.
Cognitive cost. So, like, how much mental energy we have to spend to actually use the tool.
Right. Imagine you ask an AI to summarize a really complex legal issue, and it spits out a polished, authoritative-sounding page of text.
Okay.
To rigorously verify every single claim, date, and precedent in that text requires a massive amount of mental effort. The cognitive cost is incredibly high.
It's exhausting just thinking about it.
Right. On the other hand, the rapid comfort of simply believing this beautifully formatted answer is very low.
Path of least resistance.
Human nature dictates that we gravitate toward that path. We prefer the comfort of immediate certainty over the exhausting work of verification.
We take the easy road because the grammar is so good, it basically puts our critical thinking to sleep.
Yes.
But here's the friction point for me. Sometimes the AI makes a mistake that is so wildly obvious, so completely wrong, that we actually do catch it.
Sure. Happens all the time.
When that happens, why doesn't the illusion permanently shatter? Like, how do we justify the error and just keep using the tool like nothing happened?
Well, we protect the illusion by committing a categorization error.
A categorization error?
Yeah. When an AI confidently asserts something entirely false, which we call a hallucination, most users just wave it off as a simple bug.
Oh.
They categorize it exactly the same way they categorize a software crash or, a glitch in a video game. They assume it's just a temporary technical failure.
Right, like, oh, the servers must be overloaded today. The developers will patch that out in version 5.0.
Exactly. And that is a fundamental misunderstanding of the technology.
Okay.
The source emphasizes a critical, sobering reality. Hallucinations are not dysfunctions to be eliminated.
Wait, they're not?
No, they are not bugs. They are an inherent, unavoidable manifestation of the system's probabilistic architecture.
Okay, I have to push back on that a little bit. It feels like a bit of a cop-out for bad programming.
How so?
Well, if the developers are so smart, why can't they just hard code a rule into the system that says, hey, if you do not have a verified fact for this question, output the phrase, I don't know? Why does it have to invent a lie?
Because you are still thinking about it like a deterministic database.
Right.
The AI doesn't know what it knows or doesn't know. It doesn't have an internal meter for factual truth.
It only has a meter for statistical probability.
Exactly.
Yeah.
It is under a mathematical constraint to predict the next token.
Yeah.
If you ask it a highly specific question where it lacks training data, it doesn't just hit a wall and stop.
It keeps going.
It just looks at the words you provided, finds the closest statistical associations, and generates a perfectly fluent sentence that fills the gap.
Wow.
It is fulfilling its core programming to generate plausible language. If the statistical path of least resistance leads to a falsehood, it will confidently generate that falsehood.
Okay, that actually shifts the entire landscape for me. If the system is fundamentally incapable of knowing when it's lying,
Right.
and we are biologically hardwired to believe it's lies because of good grammar, we are in a really precarious position here.
We absolutely are.
We need to understand the anatomy of these failures. Like, how exactly do these breakdowns happen in real time?
Well, the source identifies two distinct types of these breakdowns, which they call coherence ruptures.
Coherence rupture.
Yeah. And recognizing the mechanics behind each one is vital. So the first is the immediate rupture.
Immediate meaning, what? It happens right out of the gate on the very first prompt.
Yes. This is a pure probabilistic failure. You ask a question, and the very first response is a complete fabrication.
Okay.
This happens precisely because of what we just discussed. The model lacks factual data for your specific prompt, but is forced by its architecture to predict a response anyway.
Right, it has to say something.
So it generates a perfectly structured hallucination with the right tone and specific details, but it is entirely invented.
It's the ultimate people pleaser. It would rather invent a beautifully written fantasy than leave a blank space.
That's a great way to put it.
That makes sense for the immediate failures. But the document mentions a second type of rupture, which honestly sounds a lot more insidious, the delayed rupture.
Yes, or what they call architectural drift.
Architectural drift.
Architectural drift is a massive trap for power users. This happens over the course of a long, sustained conversation with the AI. It is an unavoidable degradation of the AI's coherence.
Unavoidable. Walk me through the mechanics of that. Why does it inevitably degrade?
To understand this, you really have to understand how an AI's memory actually works.
Okay.
When you are chatting with an AI, it doesn't remember your conversation the way a human does. It doesn't, like, store your first few messages in a long-term memory bank.
It doesn't.
No. Instead, every single time you type a new prompt and hit enter, the system takes your new prompt, bundles it with the entire history of the chat up to that point, and sends that massive block of text back to the server to process from scratch.
Wait, really? Every single time I hit send, it's rereading the entire transcript of our conversation just to know what we were talking about?
Every single time. And here's the fatal flaw.
Uh-uh.
There is a hard physical limit to how much text it can process in one go.
Ah.
This limit is called the context window. Think of it as a physical desk. You can only fit so many sheets of paper on the desk before it's completely covered.
So what happens when the desk is full?
Architectural drift. Let's use an analogy. Imagine the AI is a bartender on an incredibly busy night.
Okay, I like this.
At first, you give them a simple order. A margarita, no salt.
Yeah.
They remember it perfectly. Coherence is at 100%.
Right.
But then you keep adding constraints over the next hour. Wait, make that 3 margaritas. Actually, one should be spicy. And by the way, my friend is allergic to lime, so substitute lemon. And don't use the cheap tequila.
The bartender's brain is just going to reach capacity.
Exactly. The AI hits architectural saturation. To make room in its context window for your newest, latest instructions, it physically has to push the oldest instructions off the edge of the desk.
Oh, wow.
It permanently ejects the foundational context from its processing block.
So it's quietly deleting the foundational rules I gave it at the start of the chat without telling me.
Yes, it doesn't warn you. And the researchers measured this degradation, and the numbers should make anyone using this for professional work really pause.
What are the numbers?
According to the data in the document, coherence drops to 75% after just 10 exchanges.
10 exchanges, that's nothing. I've had 50 message chains trying to get it to format a spreadsheet correctly.
Yeah. Well, it gets worse. Coherence plummets to just 40% after 20 exchanges.
40%.
Yes.
Imagine you're a developer using AI to write code for a massive application. Or like a lawyer summarizing 50 pages of depositions.
It's dangerous.
You're basically talking to a heavily overworked bartender who is secretly deleting your initial vital instructions while smiling and nodding confidently at every new thing you say.
And because of that linguistic authority bias we discussed earlier, you won't even notice the drift at first.
Because it still sounds so sure of itself.
Exactly. The AI will continue to speak with absolute confidence using flawless grammar, even as it generates code or legal arguments that completely violate the rules you set 20 minutes ago.
This sounds incredibly bleak, honestly. If the AI fundamentally hallucinates immediately when it lacks data and physically deletes our instructions over time during a long session, how can we possibly use it for anything serious?
It's tricky.
Are we just walking through a minefield?
We are, but the source document doesn't leave us completely defenseless.
Okay, good.
The key takeaway is that we cannot change the AI's probabilistic architecture. We cannot force a token prediction engine to suddenly become a deterministic truth machine.
Right. The math is the math.
Therefore, we must fundamentally alter our own behavior. We have to develop what the authors call a metacognitive competence.
Metacognitive, thinking about how we think.
Exactly. It's an active, deliberate awareness of the tool's true nature and controlling your interaction with it accordingly. The authors propose an antidote, the strategy of systematic doubt.
Systematic doubt. Okay, let's deduce how this actually works in practice based on the mechanics we've just laid out.
Let's do it.
If the AI fundamentally invents facts because it's a probabilistic engine trying to fill gaps, the only logical defense is that I can't let it be the final arbiter of truth.
Right.
I have to take its claims and verify them outside the system.
Precisely. The source defines that as systematic verification. You must always validate critical facts, statistics, historical dates, or legal precedents using external reliable sources.
Like a search engine, a textbook, a primary document.
Yes. The AI can draft the structure of your argument, but you must manually verify the load-bearing facts.
Okay, but what if I'm using it to brainstorm or I'm asking it to summarize a really broad topic where I don't even know what to Google yet? How do I handle that?
That requires active questioning.
Active questioning.
You don't just passively receive the beautifully formatted essay it hands you. You interrogate the machine.
Interrogate it.
Yeah, if it says, recent studies indicate a 30% increase in productivity, you don't just nod. You reply, which specific studies?
Yeah.
Name the authors, the journal, and the year of publication.
You force it to anchor its probabilities.
Exactly. You demand the receipts. And if it hallucinated that 30% statistic, demanding the specific authors will often cause the model to either hallucinate further, which makes the lie much easier to spot, or to correct itself and admit the statistic was a generalization.
That makes total sense. You have to treat it like a hostile witness, not an omniscient professor.
I really like that framing. Don't be an audience member, be an interrogator.
But that still leaves the biggest problem. The 40% memory drop-off. The architectural drift.
Yes, the desk space.
Right. If the desk is constantly running out of space and pushing my rules off the edge, how do I stop it from forgetting the point of the project?
You have to manage the desk yourself. This is the practice of continuous contextualization.
Continuous contextualization.
You cannot just set the rules at the beginning of a chat and forget about them.
Because 10 messages later, those rules are gone.
They're completely gone.
So I have to manually feed them back into the window.
Regularly. Every few exchanges, you intentionally restate the parameters.
Give me an example.
You type, as a reminder, we are writing this for a middle school reading level. We must not use industry jargon, and the tone must be humorous. By re-entering those constraints, you force them back into the immediate context window.
You put them back on the desk.
Yes. You are constantly steering the ship, keeping the foundational rules fresh in the AI's limited memory.
It's a complete reframing of the relationship, isn't it?
It really is.
We have to move from a dynamic where we expect the machine to serve us perfect deterministic facts to a dynamic where we are basically managing a brilliant, hyper-fast, but highly unreliable intern.
That's a very accurate comparison.
We have to verify their claims, we have to constantly interrogate their sources, and we have to keep reminding them of the core project goals so they don't wander off track.
Exactly.
And if the final presentation has a massive error in it, well, it's my fault for not verifying it, not the intern's.
And that is the ultimate paradigm shift the authors are pushing for. The informed user knows that doubt is not a reaction to a failure.
It's not just a fallback.
Right. It's not something you deploy only after you catch the AI in a lie. Systematic doubt is the absolute prerequisite for using these models.
You have to go in doubting.
Yes, you are the only anchor to reality in the conversation. The machine generates plausible language. You have to demand the truth.
Man, this has been a truly shifting perspective. We've moved away from the dangerous illusion of determinism. You know, treating a chatbot like an infallible calculator and exposed the probabilistic engine underneath.
It changes everything once you see it.
It really does. We've broken down how our own evolutionary biology betrays us, making us basically suckers for a well-structured sentence. We've mapped the physical limits of context windows, explaining exactly why long conversations degrade into architectural drift.
The 40% cliff.
Yep. And we're walking away armed with a real tactical defense system.
Yeah.
Systematic verification active questioning, and continuous contextualization.
It is the essential literacy for the next decade. The models will scale, they'll get faster, but the probabilistic architecture remains. The user's vigilance is the only permanent safeguard.
But as we close out this deep dive, there is one final, somewhat unsettling thought that this entire framework brings to mind. Yeah. Something for you all to mull over as you go about your day. We've established that human biology is hardwired to trust linguistic fluency, right? We naturally believe things that are written beautifully and confidently. And we know that these AI models are only going to get better. They're going to get more fluent, more persuasive, and infinitely more human-sounding in their delivery.
Their ability to optimize for plausibility will only compound. That's true.
So here is the question. Will we eventually reach a point where our cognitive defenses simply cannot keep up?
That's the billion-dollar question.
Right. Even armed with the strategy of systematic doubt. Are we heading toward a future where we literally won't be able to tell the difference between a statistical hallucination and the actual truth?
It's a scary thought.
Because if the illusion becomes perfect enough, how will we even know when to start doubting?
When the proxy for truth becomes indistinguishable from truth itself, maintaining our grip on reality will be the ultimate human challenge.
Absolutely. Well, thank you for joining us on this deep dive. Stay curious, keep interrogating the machine, and whatever you do, never let good grammar hack your critical thinking.